Good morning, friends. Today we are going to see the polynomial multiplication using the linked list mechanism. So already we know how the polynomial is represented. Polynomial is represented by using the linked list. So in this one we are considering the coefficient as one term and the exponent as another one. So both of these things will be present for every node in the linked list. A polynomial, already we know that we are representing in the form of ax power n b plus bx n power n minus 1 plus so on jx plus k. A, b, j, k are the constants and n is the degree of the polynomial. Already we know how this particular polynomial is represented. The polynomial is represented as coefficient and exponent or power we are representing. Like this, every term is represented in the polynomial. So now we'll take an example and we'll see how this polynomial multiplication is taken. So as an example, consider that the first polynomial that we are considering is 3x square plus 5x plus 6. And the second polynomial is 6x plus 8. So generally what we'll be doing with the 3x power 2, we are multiplying the second polynomial. So 3 into 6, 18x cube. That is, the coefficients are multiplied and the exponents are added. Then 3x square into 8, we are getting 24x square. Then afterwards, 5 with the 5x, we are going to multiply these things. 5 into 6, that is 30x square plus 40x. Like that, we will be multiplying all the terms and we are going to add the similar terms and you are getting 18x cube plus 54x square plus 76x plus 48. This is the thing that we have got initially when multiplying these two things. So in this particular thing, these two terms are having the same power. So we are adding those two things and we are making that as a 54x square. And these two terms are having the same power. So we are adding these coefficients when we are placing it as a 76x plus 48. Now, if you see this particular thing, this is the way in which that particular term is represented. So 3x square is represented as 3, 2, 5x is represented as 5 and 1, 6 is represented as 6x power 0, say, so exponent is the 0. Then 6x plus 8 is represented as 6 and x power 1, that is 1 is the exponent, and 8, that is 8x power 0, 8 and 0. So when we are multiplying these two things, this is the resultant list that we are getting, or the resultant polynomial that we are representing. Okay, the node structure that we are representing is coefficient, power or exponent, and address to the next pointer. Now if you see this particular multiplication, how this multiplication is happening, we are considering this as a polynomial 1, this as a polynomial 2, and the resultant is the polynomial 3 that we are getting. How this particular result is coming, we'll see with the same example. Now, initially, we are going to multiply the terms of the polynomial 1 with the terms of the polynomial 2. The first phase of this multiplication is multiplication of the terms in the polynomial. So, if you see, initially we are considering the P1 as a first polynomial, P2 as a second polynomial, and P3 is the resultant polynomial. At first, what we will be doing is P1 pointer is pointing to the first term, and the P2 will be pointing to this one. So 3x square is multiplied with 6x. That means 3 into 6, 18 will be getting, 2 plus 1, 3 will be getting. That is the multiplication of 3x square plus 6x is 18x cube. Then the polynomial 2, that is pointer 2, is incremented to this 8, 0. So now P1 pointer is multiplied with this particular content of this P2 pointer. So 3 into 8 we are getting 24, and 2 plus 0 we are getting 2, that is 24x square. Now initially the pointer P1 is at the first node and P2 is changing from first term to the last term of the second polynomial, and the resultant third polynomial that you are getting after this operation is 18x cube plus 24x square. After this step, P1 is incremented to the P1 of next. That means in the next step, P1 will be pointing to the 5x and P2 will be once again starting here. We will see that second step here. So now P1 is pointing here and P2 initially starts at this point. So 5 into 6 is 30. 1 plus 1 is 2. That is 30x square that we are adding at the end of the polynomial. Next, 5x is multiplied with 80. That is, P2 will be pointing now to this one. 5 into 8 is 40. 1 plus 0 is 1. 40x that we will be getting. That is, when the pointer P1 is pointing to the second term, P2 will be changing from the first term to the last term of the polynomial 2. And whatever the resultant nodes that we are getting, we are adding at the end of the third polynomial that we are having. Now we'll go to the third step, that is P1 is incremented by to the P1 of next. That means P1 will be pointing to the 60 in the next step, and once again P2 starts here. So 6 into 6 is 36, 0 plus 1 is 1. That means 36x. And 6 into 8 is 48, 0 plus 0 is 0. That means P2 will be changing from the first term to the last term, and these are the two new terms that are added to this particular polynomial called as third polynomial. So this is the resultant that we are getting after the first phase, that is multiplication of the terms of the first polynomial with the terms of the second polynomial. Now we'll go to the second phase, that is we want to remove the duplicates. Where the duplicates are there? If you see, a polynomial does not contain the two terms with the same exponent. So that's why the duplicate terms are with the power of 2 we are having the duplicate, with the power of 1 we are having the duplicate terms. Now we have to remove this particular duplicate terms. For this purpose we are going to the phase 2. In this phase 2, initially we are considering the P1 here and the P2 also here. Now P1 is compared with P2 of next. That is, P1 is compared with the P2 of the next. So the P1 exponent is 3 and P2 exponent is 2. So there was no equal exponents here. Now P2 is extended to the next one. That is, P2 of next equal to P2 of next of next. That means now P2 of the next will be pointing to 32. So 2 and 3 are not same. Like that we'll be comparing up to the end. There was no duplicate powers with the power 3. So the resultant after this step is the same thing. There was no change. Now we are starting once again P1 at the second node, and P1 of next will become as the P2 of next. That means P2 will also be starting from here only. We are comparing is there any duplicate terms or not. So generally there was no need that P2 has to start here. P2 will be starting here, and we are comparing P2 of the next with P1. Now if P1 of exponent and P2 of next of exponent both are same, that means a duplicate terms are there. In this situation, so to the P1 of coefficient, P2 of next of coefficient is added. That is, 30 is added to the 24, that we are getting the 54. And we are going to remove this particular duplicate term that we are having. So the duplicate term is removed and it will become as a 54x square. Okay. So, and I will compare P2 will be going to the next term, P2 of the next will be going to the P2 of next of next. So it is 2 and it is 1 because it is 54x square and this is 40x, x square and x are not same. So I am comparing like this up to the end. So there were no other terms with power 2. Now I will go to the third step. P1 will be going to the next term and P2 will be starting here. P2 of next will be this one. I'll be comparing P1 of exponent with the P2 of next of exponent. Both the exponents are same. So we are going to add these two terms. 40 plus 36 we are getting 76x, and P2 of next will be going to the P2 of next of next. So this is 0 and this is 1. They are not the same. So at the end we are getting, that is, these are the things that we are getting. So this term will be removed and only 76x will be present. If the P1 will be coming here, the P1 of next is null. So there are no other terms. We are ending our process here. So this is the way in which we are implementing the polynomial multiplication. Now we'll see the program for this one. This program, except the multiplication function, all other functions are same as that of the addition of the two polynomials. I am taking the structure node. So it is consisting of exponent and the coefficient and a pointer to the next node. And a pointer to the next node will be present. So I am taking the three polynomials, start 1, start 2 and start 3. Start 1 is for the first polynomial, start 2 is for second polynomial and start 3 for the third polynomial. And display function is same as that of the previous one. It is starting at the start and we are displaying up to the last node, and we are displaying like this 5 that is coefficient and the power, pointer of coefficient and pointer of exponent. After displaying one term, you are going to the next term. After the display term, already we know about these two functions. Add node is the function that we are using for adding a node to the third polynomial, and the create polynomial is the function that is used for the purpose of creating initially the two polynomials. So at first we are taking the add node function. This add node function is creating a one node by using the malloc function. That is, new node is created, and for the new node of exponent we are placing this particular n, and new node of coefficient we are placing this particular c, and the new node of next is null. If there were no other nodes that are present in the polynomial, that is, if the polynomial is empty, our new node will become as the starting one, or otherwise you are adding that particular node at the end of the polynomial. That is, pointer is starting at start, while pointer of next is not equivalent to null, pointer equal to pointer of next. I am going to the last node. To the last node's next, we are placing this new node. And this is the create polynomial. This is used for creating the polynomial 1 and the polynomial 2. So I am performing this activity until the operator that you are giving is yes option. So you are taking the coefficient and exponent. Always know that in the descending order only we will be placing the coefficient exponents. So I am reading the coefficient and exponent and I am creating the node. Like this, I am creating all the nodes until you are pressing yes. Once you press any other key other than Y, I'll be creating the nodes for this one. Afterwards, I am coming out when you are pressing the other than Y. That is when you are pressing Y, and I am displaying the polynomial. Okay. So now we'll see the two functions remove duplicates and the multiply. So at first we'll see the multiply function. So this multiply function is multiplying the two polynomials and placing into the start 3. So now P1 pointer is pointing to the first polynomial, that is start 1. P2 pointer is pointing to the start 2. And we are performing this activity until P1 is not equivalent to null and internally P2 is not equivalent to null. At first I am starting the P1. So I am taking the P1. P1 is multiplied with the terms that are present in the second polynomial. That is, P1 of coefficient is multiplied with P2 of coefficient, and P1 of exponent is added to the P2 of exponent. I am taking this as a coefficient and exponent, and I am adding this new exponent and coefficient to the third polynomial, that is start 3. This activity that we have performed in the so in this example, when we are considering the P1, so P1 of coefficient is multiplied with P2 of coefficient, and P1 of exponent is added to this P2 of exponent. These things, that is 18x cubed, is added to the third term. That activity that we have performed here in this step. After adding these things, and P2 is incremented to the next term. Like the multiplication polynomial 1 term is, that is, one node of the polynomial 1 is multiplied with all other terms of the polynomial 2. Then once again P2 starts at the second polynomial starting and P1 goes to the next term. After completion of this one, we are removing the duplicates that are present in the third polynomial. That we'll see here. So see here, so P1 polynomial P1 is starting at one place, that is called as start, and when the P1 is not equivalent to null and P1 of next is not equivalent to null, I am performing this activity, and P2 is also starting at P1. So until the end of the P2 that we are performing here, so we are comparing P1 of exponent and P2 of next of exponent. If both are equal, I am going to add the coefficient of P1 of coefficient and P2 of next of coefficient, and I am removing the P2 of next. That we have seen in the diagrammatical representation. See here, P1 is starting here and P2 is also starting here. P2 of next we are considering. P1 of exponent is equivalent to the P2 of next of exponent. In such case, I am adding P1 of coefficient and P2 of next of coefficient to this one. This is 54x square, and P2 of next is removed. This step is performed in this particular activity called as removing of the duplicates. And after completion of the one term, I am going to the next term. Otherwise, if they are not equal, I am going to the next term. Like this, I am doing this activity of the removing of the duplicates. And this is the driver program. I am creating the polynomial 1 by using the create polynomial, polynomial 2, and I am multiplying these things. So